So this problem in part A, we're asked to sketch the convolution of a Gaussian function which is symmetrical about x equals 0 with a delta function positioned at x equals 0. So we can sketch the two functions. For the Gaussian function, we're going to have something that looks like that. That's x equals 0. So we'll call that f of x. And for the delta function, we're going to have essentially a spike at the origin like that. So that's x and that's also x, and we can call that g of x. So when we take the convolution, we have to think of moving one of the functions through the other function, and as we move it through that, we have to plot the overlap. However, we showed in the notes that the convolution of a delta function with another function is essentially the original function, although its center will be shifted to correspond to the center of the delta function. Now in this case, the delta function is at x equals 0, so we can write down that g of x star times f of x, where this is the convolution, is simply going to be the original function. So in this case, we would get a result that looks like this. So that's x equals 0, and that's the x-axis. So in the first case, we just get the original function f of x. In the second part, part B, we now have two delta functions, one at x0 and one at minus x0. So in this case, g of x will look like this. So this is g of x, and we have a delta function at x is equal to plus x0 and 1 at minus x0. And again, we have to think of what happens when we sweep our other function, in this case our Gaussian function, through these two delta functions. And essentially what happens is each of the delta functions produces a Gaussian function in the answer. So the answer would look something like this. We would get a Gaussian function there, and then we'd also get another Gaussian function over there. And the point in the question about the widths of the Gaussian functions being much smaller than the separation just means that we get two distinct Gaussian functions. Obviously, if the widths of the Gaussian functions are large compared to 2x0, then the two Gaussians will overlap. Okay, so that's the answer to part B.